Dear friends and members of the KITION Planetarium Observatory, good evening. Another online science cafe with an interesting subject. Tuesday, the 27th of May tonight. And we have a special guest, our space scientist here at the KITION Planetarium Observatory, our beloved Katie Demetriou, a space scientist. She studied at the University of London. She also worked for the European Space Agency for remote sensing. And she's going to talk to us about the modern space race. And it's a very interesting subject. We are summarizing it today because of the Science Cafe, but we want to have another discussion, and we're going to go deeper into the subject. But let's wait for some landings to occur in 7-8 days, and we will see. We add more to this presentation, and we'll go in more details. And after that, we'll inform you about Asteroid Day Cyprus that will occur on the 30th of June. And also, I will inform you about the celebrations for the International Children's Day on the 1st of June. What's going on here on that day? So, Katie, thank you very much for being with us tonight. You may proceed with your presentation. Let us learn more about the modern space race.
So, hi everyone. Like George says, I am going to just explain what is going on recently. There's been a sudden surge in space missions in the last couple of years. So, I'm going to go over a few of the very prominent missions and what they've done and why they're doing this. So, well, basically, the modern space race is like a really dramatic resurgence of exploration and development. It's never been like this before. Before it was the space race back in the 60s was who was going to get into space first, who was going to go into, orbit the Earth first, who was going to get on the moon first. And it only involved two main players, the USSR and USA. Now it's completely different. There are many, many, many players, national agencies, there are private companies. In fact, it was a little bit overwhelming looking at how many private companies there are involved in the space industry at the moment. I found this infographic and it shows you what's been going on in the last 3 years. So as you can see, this is 69 global orbit launch attempts in 2025, only in the first quarter. So that's in January, February, March. And you can see that there's a significant increase since 2022. And you can see that it's not just US anymore. There's an increase in other countries as well, which is surprising, but not actually surprising if you think about what's at stake and what's the reasons for these missions. So I got this from payloadspace.com. So modern space race players, like I said, there's like 77 national agencies and hundreds of companies, like including small startups and including massive ones. So I class, like, let's say the biggest 7 groupings. So number one, we have NASA from the USA, very famous. Like they're into big telescopes. They still do very, very ambitious missions like the Artemis mission that's coming up to put people on the moon. Okay, so a very big player still, no matter what the politics in the US is, they will continue to be a big player. Second, believe it or not, in spending is the China National Space Administration. They've, like I said, grown exponentially. They have now got a space station. They have a constant presence in space with astronauts in space, and they've had multiple missions now to the moon, successful missions, which I'll talk about one of them later on today. And then we have the European Space Agency, that consists of many countries with their own space agencies. And what's good about the European Space Agency is a very collaborative approach, just like the European Union is. It involves other countries that aren't in the European Union as well. So it's collaborative. They're very into Earth observation, which is helping our planet observe various phenomena and trying to find solutions to some of the big pressing problems on Earth from space. And they also do big missions as well, such as JUICE. So that's the previous time that we had a presentation about space missions here. Then we have got Roscosmos, the Russian space agency. They're influential. They have lots of deep space exploration programs. They are developing really heavy launch systems, so used heavy launch systems. And also, they are also in collaboration and working with other countries. We have the Indian Space Agency, this Indian Space Research Organization, to be precise. And they've had very big successes recently. A Mars orbiter, successful, human flight. They've had a series of they've got a series of lunar missions that have also been successful. And we have also, I disappeared off my screen, did the Japanese Space Agency show up there? Because it's hidden, JAXA, Japanese Aerospace Exploration Agency. So they are experts at sample return. Okay, so previously for the KITION Planetarium, I've spoken about their sample returns missions like Hayabusa 2, very successful, again, very collaborative. And you find that JAXA is involved in many other projects involving these space agencies. SpaceX is a big one. This is the first commercial enterprise developing reusable Starship systems. Starlink, they're also heavily involved in the NASA Artemis program, cutting costs for the US government. And then finally, you've got another big one further north, the Canadian Space Agency, and they're very specialist on robotic arms, and they're providing a lot of things, again, for the Lunar Gateway that is going to be built to actually bring people back on the moon. Now, I did get overwhelmed when I looked at the list of private space flight companies. So if you want to just go to Wikipedia and see how many there are, it's pretty amazing. Now, why is this space race happening now? Okay, so you can see that I've got some pictures of some reusable rockets. These are SpaceX's. I've got Richard Branson here. He's got a program for tourists. There's also commercial aspects. So in the center of the screen, I have a illustration of what could be the future, which is involving asteroid mining, because there's precious resources in space. We're running out of our own resources, so we need to go somewhere else and look for resources. And one of the big potential of this finding these resources is space and asteroids as well. And then finally, technology has improved leaps and bounds, and now there's many opportunities to make microsatellites and do things with microsatellites such as CubeSat. So even institutions such as high school, they can actually get something into space with technological development. So basically it comes to three things. We've got lots of technological advancements. Rockets are more powerful, they're reliable, they're affordable, they're reusable, and there's lots of innovation in the propulsion system. And the second thing is, like, the biggie is economic potential, like space tourism and asteroids mining, and some resources that you might find on the moon that aren't available on the Earth. And then the final thing is there is also still, like, the beginning, that geopolitical ambition, the fact that I want to be the first person on Mars. We should have a moon base. We need to show our presence. So there's also that aspect that is actually driving the space race, just like the old days at the start of the original space race. So I'm going to just go through, like I said, some of the missions that I think are super, super important. Now, the biggest amount of missions I'm going to talk about today are missions to the moon. So the moon is the #1 target for many, many, many missions, just because of the potential there. So there's a potential that we can actually get people living on the moon. That would be the gateway for us to explore further in the solar system. And a main place for these missions to land to research is the lunar South Pole. Now, on the lunar South Pole, you have water. Water can be used for obviously sustaining life. It can be used as a fuel. And you have the sun hits the South Pole pretty consistently, and yet you can have areas in craters with shadows. So it might be a good place to put a moon base and have it protected. So many of the missions that have been launched in the last 2-3 years, they have that objective to explore the South Pole for these reasons. So India, very successful. They launched their own mission to the moon, and it landed successfully. The Vikram lander and the rover landed on the South Pole, and it was the 4th country only ever to achieve a successful soft landing on the moon, and the first to land in the South Pole. Success. All right, so they're planning further developments, like I said, and they're going to build on the success that they have. Now, Luna 25, Roscosmos. So the Russians want to go back to the moon, and again, it was many, many years since there was a Russian mission to the moon, and this one got launched on the 10th of August. It was again the South Pole. It was again to test landing technologies and explore the area further. Search for ice, search for water. This mission failed. Okay, so the actual mission, the lander, it crashed. This is a picture that it managed to take. So on the left-hand side of the screen, you see one of the pictures. So it wasn't a complete failure. It did get on the moon. It took a picture. You can see the surface of the moon behind the crashed lander. So a good testing phase, good to show resilience, good to build on the mistakes. Not a complete disaster. Now we come to this one. So this one is from one of the smaller space exploration agencies, so JAXA. So it was a smart lander, SLIM, for investigating the moon. And as you can see there on the right-hand side of the screen, it was a success. Okay, and it also released tiny micro rovers to go on the surface of the moon and explore more. The image at the top is actually an animation of these micro rovers. So the target was the moon. It pinpointed landing technology, and it conducted scientific investigations of the landing area, and it was a success. So they were the 5th country to land on the moon. It wasn't a complete success because the actual lander was upside down, and it could work when the sun was favorable, because of course it didn't land the way that I wanted it to land, but still it's considered to be a big success. Now I'm going to go a little bit away from the moon now. Okay, so remember we said that one of the other aims of the other goals of this space race is to actually look at resources, or look at study what happened in the early solar system. So Psyche is something that was launched in 2023, and previously I've talked about this mission as something very, very special, because it's going to a metal-rich asteroid. Okay, so the metal-rich asteroids, you can kind of find their composition remotely by looking at the ways that electromagnetic rays are emitted and reflected off the object, but it's not as good as actually going there. So this mission is going to go to this metal-rich asteroid, which could be the actual core of early planetesimal that that could be similar to like our core. And so it's going to understand, we're going to help really understand how the solar system forms a little bit better with this mission, as well as actually being the first mission to go to an iron-rich asteroid. And so that's in the future. It's very taking its time to get there. It's on a number of flybys and gravity assist to actually save on the energy. So 2029, it will go there. Now, we come to a commercial one. So this was launched last year, and it was a commercial enterprise, and it was under the umbrella of NASA called Asteroid Peregrine 1 Mission 1. And it was to develop the technology to just deliver payloads and do some demonstrations on the lunar surface. It failed. Okay, so after launch, it had an anomaly and it didn't even actually do a landing. Okay, so this company obviously didn't give up. They're still working on the next mission to the moon. Now, this is another commercial one. Okay, so again, under the umbrella of NASA, it's a commercial drive. It was a commercial drive to go to the moon. And again, very similar objectives as the previous one. Okay, but this one actually made it. Okay, so it was the first ever commercial spacecraft that wasn't under this big national agency to land on the moon. And it was the first American object to land successfully on the moon since Apollo 17. Okay, so it landed, it operated, and it was a big success. Now we're going to switch. We're going to go to the other side of the world, opposite to the USA. Now, like I said at the beginning, China has been working hard to develop their space-based technologies, develop this collaboration with other countries, and to be a world leader in space exploration. Part of this was this mission. So to have a lunar base or to have good communication to your landers on the moon, you need to have telemetry, you need to have relays, you need to have communication. So this particular mission was a success because it launched into lunar orbit and it is successfully providing communications for the actual lunar landers that are on the surface of the moon at the moment. So a great success. So this one is something really close to my heart. So its objective is to go and go to one of the most interesting moons in the solar system. That's Europa. Okay, and to investigate to see if there is actually water under its ice shell, if there could be signs of life. It's going to form a lot, it's going to do a lot of flybys close by and study this amazing moon that we can see through our telescope in detail and give us some clues as to what is going on. And it's going successfully so far. So that's the Europa Slipper. And I had the pleasure actually of meeting one of the scientists who's very involved with that. He gave us an online talk, and I'm still in contact with him. So he's someone to speak to in the future about what's going on and getting an inside view of this particular mission. Now, there's protection as well. So asteroids pose a threat. And we've already had a ESA mission called, a NASA mission to nudge an asteroid a bit. So there'll be NASA's DART. It impacted on an asteroid in 2020 to see what would happen. Now, ESA is following this up. They sent the HERA mission into orbit to actually study in more detail what happened. So this is going to give us very, very useful information about the impact of that first mission by NASA. Again, it shows good collaboration, and it's something that is going to design, it's designed to see what the effects are of nudging an asteroid, to see if in the future, if we have a potentially hazardous object coming to Earth, if we can actually use this data to prevent a hit, which is very similar to what we're going to talk about on Asteroid Day, isn't it, George? Yeah. Now, back to the moon. So again, the successes start coming. So there's been a few unsuccessful missions, but they are followed by success. So this is another commercial mission to the moon under NASA's umbrella program. And again, it was very successful. This delivered the payloads. It actually met its objective. It delivered experiments. The experiments are working. And I really love this photo. It's a picture of the stazo. It's actually from the moon. The picture of the stazo of the lunar lander. And you can actually see the Earth up in the lunar night sky. Okay, very, very cool picture. But again, a successful commercial mission. Now, we go back to yet another one, but this is not a commercial mission from the US. This is a Japanese commercial mission. So again, this objective was to deliver a lunar lander and a micro rover to the surface, and it was successful, and it should be landing soon. Okay, so this should be landing soon. So far it's successful, and like in the next few days, we will be able to see if it is completely successful and is able to land. So this will be the first commercial mission from a non-US company to land on the moon. So at the moment, it's in the lunar orbiting phase. I believe I read that something is going to land on the 29th of May. And so it's something to watch, and we'll announce the news as soon as we find out. Now, another successful, well, launch mission, but that it kind of crashed, this one. It was again under this program from NASA. Okay, so far we've had like many companies that have the money and the drive and the technology and the personnel to get things on the moon, which is pretty amazing. So this was launched, it got on the moon, it tipped over on its side, it had touchdown, and some operations were complicated because of this, but still. And it's one of these experiments to search for water ice, which will be essential for the next step. So the next step when humans get on the moon again and try to set up a permanent base on the moon. Okay, so here are some of the landing sites. Now, the near side of the moon is the side that we see. And that's where the old space race site, where the Apollo landings took place, there on the near side of the moon in the Mares. Now, the new sites that these missions are landing on, these commercial missions and the missions from the other countries, are not exploring those areas. They're exploring the more interesting areas for them, which is the South Pole, where there could possibly be a lot of reservoirs of water, and also the far side. So the far side is the side that we can't see, which has a very different geology to the near side. So you can see here on the near side, you've got these dark areas, the mare. And on the far side, you don't have them. So it's a kind of a different terrain. And by studying the far side, I mean, we need to put landers there. We need to study it, take samples, find out more about the far side, because it could lead us to big clues as to how the moon forms. And this one is the big one. Okay, so this one is an amazing mission. And it was very, very successful. So the China National Space Administration, they launched this last year. It was for the lunar far side of the moon, and its objective was to get samples from that side and return them to Earth so we could study them in the lab. And it was a big success. It is such an important mission because it was a fully automated landing, fully automated sample collection and return. So it's a big step into like developing technologies that are reliable and safe because it's all automated. It returned also the collected sample returned successfully, delivered back to the Earth. So now the Chinese have 2 kilos of rock that we've never actually been able to study in a lab on Earth before. So this was really a keystone mission that was extremely successful. Now, it is also really important because it's the first step to actually getting that lunar base there in that area that is really conducive, we believe, to actually being able to stay there permanently. And basically that is China's next goal, just like it is the US's next goal. So they are going to put a permanent robotic station on the South Pole, and their aim is to take astronauts there by 2030, which isn't actually that far away. So we have this really exciting time, the next space race, like who's going to get the next person on the moon first? How long are they going to stay on the moon? How are we going to set up these spheres or these permanent lunar bases that can then lead us to the next target? And the next target is, for most people and most agencies, the planet Mars. Okay. So here is an idea of what is going on in the moon. So this is the landing site. This is the far side of the moon, and it's the landing site. And it was spotted by another orbiter. So it wasn't. This is a picture from NASA's Lunar Reconnaissance Orbiter, which has been operating for many years successfully, monitoring and relaying communications and taking images. So NASA's Lunar Reconnaissance Orbiter took a picture of the Chinese mission's landing site with the actual lunar lander there. Now, I've finished going through the current missions and the last few years that have been to the moon, successful and unsuccessful. And you can see that there's a pattern here. In the last year, they have been successful. So it's really, really like amazing, like what we're looking forward to now. So these missions are in the very near future. So we have Griffin Mission 1, Astrobotic, the one that failed before. They're carrying on. They're going to try and get another lunar lander on and be successful. There's Escapade that is going to be launched in autumn. And then the Chinese are actually going to do a sample return mission as well to asteroids and an orbiter, etc. And that is planned in May. And NASA is going to put another orbiter very shortly in 2026. So we're looking forward to lots of more missions to the moon. So I mean, if you think about it, there was not really a lot in going to the moon for many, many years, and then suddenly this big influx. And suddenly all of these other countries, private companies, so it's the next target, and hopefully all of this research will lead to very successful missions to the moon involving humans in the future. Okay, so I hope you enjoyed my roundup of the last 2 years of missions to objects in our solar system. And are there any questions?
I have a stupid question about Hera mission. Can you
Yeah.
return there?
Yes, sir.
There is a poster, and it seems to me a kind of dinosaur. Why they choose it?
Yeah, so this is an Easter poster. So what was your question? Why they chose?
Yeah, what's the reason for dinosaur? At least it looks to me like a dinosaur.
Yeah, I think it's because of the impact that is thought to have led to the extinction of the dinosaurs, I guess.
Ah, yes,
Mm.
exactly.
Yeah, I think maybe that is. I didn't even see that, Alexander. Well spotted. I
The
just thought it
balloon.
was funny with the beards on the like with their expressions. Anyway.
And can you show the Chinese Chang'e 6 load? Yeah, this one. How many kilos they return back?
2 kilos, I believe.
So
A lot.
larger than anything they did before.
Yeah.
Yeah, previous was
Like
1,700 something
yeah.
grams.
And if
And
I
it all
remember,
completely automated, like amazing.
well, that the Sanjay 6 sent more images on the past side of the moon from all missions since the space missions to the moon in a very, very small period of time.
Yeah. And you know, like I said, the telemetry between this particular lander and the other mission is amazing. You know, you need that telemetry to be successful.
Mhm.
Mm.
So,
We have question of Daniel.
Dr. Demetriou, for your very interesting presentation. I have two questions. Indeed, our modern space race is a race for resources, as you tell us. But I think the interesting part for us is when do you think the humans will return to the moon with a human equipage? It will be next year in 2026 with Artemis 3, which they said, because now we have more than 50 years after Apollo 17, the last mission to, if I am not wrong, to the Mars. First question, and the second one, continuing with this, in how many years do you think the human will be possible to land on Mars?
Right. So basically, as you know, the
Scientifically speaking, not with
yeah. So yeah, it's scheduled that humans will fly around the moon in 2026, but landing on the moon, like I know the Chinese are planning in the 2030s to land on the moon, and I think NASA has the Artemis program, and they're going step by step. So their program, every time they're starting the next phase of the mission, it's being delayed. So
yes,
my estimate is probably 2032, and like I think because I can see this progress. So I think 2032, 2035.
Not at all next year, 2026.
No, I don't think. I don't think.
Don't think so.
Yeah, because I know that I think they're just going to. It's just going to orbit the moon. But it's not like the old space race because I mean the amount of testing that is going on now, the amount of research and missions is not the same as the old space race. I think putting a human into space and taking them that far is not as, it's not like before. Now Mars, we haven't even got a sample back from Mars yet. So, you know, the current thinking is if you take a human to Mars, that's it. Like, so if we haven't even been able as scientists and engineers on Earth to get a sample back from Mars yet, that probably is going to take a lot longer. I would say it will definitely be I would hope it would be within our lifetime. Maybe maybe I think that would be like maybe 15 to 20 years.
20. So
Yeah.
I reformulate. We can. Do you think we can see in our lifetime landing to Mars?
I think, yeah. I think I think we will, because I mean, like I said, the commercial drive. The commercial drive is. This is what's so different about the previous space race. You have so many different companies, so many doing successful things that wouldn't have even, you know, if you said 10 years ago that you know, some 3-4 private companies are going to land on the moon,
That's right.
no one would have believed you 10 years ago. Yeah. So yeah, I hope in our lifetime that someone will successfully stand on Mars.
As I could see, thank you, Daniel. Chan 6, you said that it is completely robotic, and it is actually good because of it is check of the technology, because of in 2031 they want to return back sample from Mars. And at Mars, everything should be robotic.
I know.
As much as possible. And that's why if they managed with Farsight, and Farsight was chosen to show that, yes, it's impossible to interfere. So no contact. Yes, they have this relay, RD, but that's all. So it's not direct interaction. So if they manage to do it like this now with the moon, so they may. The next step for them is to do it in 2031 with sample return from Mars, and they want to go to Mars as human in 2050. So in next 15 years during great opposition of Mars. But as far as I understand, you mentioned already some are returning to Mars. Some missions to Mars are already started.
I think.
Yeah.
Will they? Can you show?
So some missions, I think some missions to Mars are in the drawing board. I don't. But I mean, like the sending of humans to Mars is absolutely ridiculous if you think about it logically. At the moment, you know, it's more of a prestige thing. But why it's like this
technology.
Yeah, it's this drive, you know, this drive, like the third point I talked about on the first slide. It's something about pride and exploration. It's not really about science, is it? At the moment. But hopefully we will see that it's good entertainment at least, and it drives forward the technology, and what spin-offs we have would be amazing if you consider the spin-offs of the old space race.
Sorry, Hesret have another question too.
Yeah, we have chat. Welcome.
Hello.
Hi.
I would like to, first of all, thank to the planetarium to make this event. And thank you for these explanations. The presentation is awesome. I'm very much excited to hear, because sometimes I think that we are in the science fiction film because everybody wants to go to outer space, and most of the time they're successful. What I would like to ask is that I know that there is an outer space treaty. For example, what I see in my monitor, the Changi 6. For example, everybody is going to the moon, to some other asteroids, or they want to go to Mars and other things. Who decides about that the mission is successful? Because, you know, if I go, I can say that I have been successful. Is there any committee that decides about the success of the mission? And what I am interested is that, because, you know, there are some news, some humors in the websites and TV and other things. They say that, okay, they bring this and they found, for example, small things like microbes or other valuable precious stones. Is there any specific website, or is there any specific committee, or is there any country that can make the explanations really what were the conclusions of the missions?
Okay, the international, hello Hasret, it's George. The International Space Treaty for Space was signed on the, if I remember well, on the 10th of October 1967, 10 years after the first launch of Sputnik. That's why we also celebrate the World Space Week between the 4th and the 10th of October, because of the Sputnik, the first launch of a satellite from humans. And on the 10th of October, it was the signing of the International Treaty for Space for the peaceful uses of space. That's what the treaty says. Now, I am not sure that the treaty is related to the success of a mission. Now, for every mission, there are some targets to achieve and some objectives. Now, if there is a list of objectives and all these targets, these objectives are achieved, then it's a fully successful mission. If they partly succeeded, then it's partly successful. Now, if there is a failure in the landing, so of course they will gain some knowledge and experience of the mistakes that are done, or some errors they haven't calculated, or some conditions that they led to this crash, or unwanted bad landing. And of course, it will be some kind of success as well. So nobody will accept that they spent so much money for a failure. Now, as far as I know, for NASA, they are planning to send a man and a woman with the Artemis 3 mission that will be launched mid-2027. So this is what I found on the NASA website. And I remember well when we had an event with the Russian embassy and there was a cosmonaut invited. He told us that Russia is planning to send someone on the moon, a cosmonaut on the moon, if I remember well, 2026 or 2027 as well. But there was a latest announcement on March the 13th that Roscosmos said that they are actually now spending a lot of time focusing on 3 missions. Luna 27 that will land on the South Pole and study the water and ice and some minerals, and Luna 28 that will go and bring some samples back, and Luna 29 that will send a very large rover. So foreseeing the future, it should be between 2027 and 2030 that we will land a man on the moon. And if I remember well, that we have mentioned a date in our Mars presentations here, it was 2037 that it was estimated that they will send someone on Mars. Now, I'm not sure that it can be successful, but you know, SpaceX also has some surprises to us, and it works without bureaucracy like the international or national space agencies. So they achieve things faster and cheaper. If I may add to the previous, to the lecture, with all this that we see that a lot of failures and a lot of trials to land on the moon of a small rover, if I was not a scientist and if I was not in some international meetings talking about some lunar missions from the past, I would have taken already the skeptics' position that they would say that nobody went to the moon yet. But it seems that it's difficult, and I don't understand how they really achieved it, but I'm sure that the Soviets would, of course, blame, accuse some of the Americans that they didn't do it right and so on. But I have talked with a Russian cosmonaut 2 weeks ago, and I asked him this question, how, and he gave me not a clear answer. So he invited me to his house, and I will not reveal his name for obvious reasons, but I will give you a straight answer next time, I promise. And so that's it as far as the future missions are concerned. I had this study, and India is planning to send astronauts in space in 2027 from their own launch pad.
Yep.
It was excellent work, excellent presentation, Katie. Everything gathered together, and a lot of missions. I'm intrigued, but I saw earlier in the evening that some mission will land in 7 days. So but I don't remember which one was it. And there was one.
Hang on, let me show you. Let me go back. Hang on.
One landing.
My slideshow's frozen.
No, it's
this one. This one, yeah.
Yeah.
So yes.
I think one of them is scheduled to land on the
but this
29th.
2025.
Yeah.
But
no, this not the
no,
which one is it?
I think the Chinese.
Yeah, it's the which one was it? I know there's something landing soon.
I read it in space.com. I remember.
No, there's something landing on the 27th. I saw it in
space.com.
Just pass slowly, and that's all.
No.
Yeah, this one, this picture.
Yeah, it's the Japanese one that I was talking about. Yeah.
I like the Japanese
concept. The private company,
because of they concentrate on nanotechnology.
Yeah,
and actually it's good idea because of, for example, you may send many nano robots on Mars or on the moon, and they will do this work hundreds small pieces everywhere, and they will give you a general picture much more easily than when you send huge robot at one only place, which makes everything clear, but only one spot on the huge planet.
Yeah, there's that issue that Hazret was talking about the pollution. So we're going to pollute other objects in space now. There's that as well.
Actually, I have a question about south pole of the moon. Moon is tilted, and that's just small tilt, just few degrees. But nevertheless, if we need the spot where we have ice on the moon is smaller than this tilt. So how long, how it is solved? If someone wants to be there for a long time, half of year there should be darkness. How it is solved? It is solved.
I believe that they're looking at the dimensions of the craters. So you know, some of the craters, they have different amounts of, like, let's say shade. So you can use that to pick. So it's not, you know, this stuff about a Shackleton crater, the rim is always in the shade, and so that's partly why you have so much exploration around the South Pole, to actually measure the temperatures and see what's going on before you send a lunar base there. Yeah. So that's the thinking behind the South Pole, and the fact that you've got to use craters.
Okay. Anyone more questions, or shall we proceed
Yes,
with
we
that?
have question of
Okay.
Dennis.
Yes. Why haven't there been more missions targeting Venus compared to Mars, since I believe that it is closer to Earth?
There is going to be
Yeah.
another mission from the ESA to Venus.
I mean,
yes,
there's also the fact that you've got to you know, the conditions are so harsh. So if you send any kind of lander or probe or anything, it's not going to last very long. So there's also that I mean, there is also, I think Roscosmos is planning one to Venus as well, if I believe. So. Yeah, Venus is also something that you need to study. And missions to Venus, they're not, there's not as many, but there are some in the pipeline.
Recently finished its operation just according to plan. Japanese satellite which orbit Venus, just orbit, nothing more, and just collected data about weather conditions on Venus, and radio location obviously shows the surface. And so it was the last what we had. After that, only flybys.
No, we had orbiters. We had Envision.
Japanese was the last it landed. It stopped. Then NASA and European Space Agency are going to make a rover, clockwork, so it will work without much. There will be electricity, but not much. Here we have two people, George Troullias and Katie Demetriou, who judged Cyprus students at NASA Space Apps. Yeah, and the winners were those who developed some element for this mission. And Roscosmos is going to repeat achievement of Soviet Union Venera 13 and 14, because of Venera 13 had to be on the planet on surface only 30 minutes. After that, everything will be destroyed just because of temperature. But they managed to practically 2 hours. Now the aim of the next mission for 2031 or something like that around for Roscosmos is to stay on Venus half an hour. Oh, sorry, 2 hours. So that was achieved in 1981. Should be repeated again like a must. So 2 hours should be, maybe longer, but 2 hours should be should be operated. So that's about Venus. What is going on?
It's going to be a launch from ESA. It says here the Envision. ESA's next Venus mission is Envision, an orbiter designed to study the planet's history, activity, and climate, and understand how and why Venus and Earth evolved differently. These will be scheduled to launch late 2030s with a primary target of November 2031. I found this online now. Excellent.
Some more questions? Thank you, Katie. Shall we proceed?
Yes, let me share my screen, please. I'm sending you a request for the screen.
Like, got my share, hang on.
Okay.
Okay.
Okay. So guys, the second subject today is Asteroid Day. It's going to be a summarization, and actually an introduction of what we are celebrating on the 30th of June every year. This is a global initiative actually that started many years ago, and now is the 10th year that we are celebrating the Asteroid Day. So we have a new logo for this year, one in front of the asteroid, which is representing 0, so 10 years. And actually, Asteroid Day is a global movement that helps to protect the Earth from asteroids, and we want to increase the awareness, and we want to persuade the governments to invest in projects like for the protection of Earth from asteroids and from near-Earth objects. And we have the so-called 100 times declaration that we using all the knowledge gathered together and sharing knowledge and equipment and technologies, expanding the ability to discover more asteroids, and we are achieving that. In our event, during our event on the 30th of June, we are going to talk what we commemorate on the 30th of June. Actually, we commemorate an event that took place in June the 30th, 1908. There is no crater where this thing happened. There was an explosion, but there's a forest diameter of approximately 50 kilometers that the forest was devastated because of an explosion. It could be an asteroid of very large diameter that actually exploded before. Some people say it could have been a comet, and it was so large that the explosion was heard 1,000 kilometers away, and some people were kicked from their porches, from their houses because of the sound blasts. So we're going to hold an event on the 30th of June. It's going to be on Monday, 30th of June, 7 o'clock Cyprus time, here at the KITION Planetarium Observatory. I will do a welcoming, and I will inform everybody about, in more details, about the International Asteroid Day movement. For sure, we will have an international broadcasting, and I will share it on the group, online on the website. And during that event, we're going to talk about new discoveries in the asteroid belt from the whole world. We're going to announce a new number, and also we're going to announce our 8th and 9th asteroid discovery that we did here at the KITION Planetarium Observatory. Hasret, we are waiting for you in the next asteroid search campaign. And I think you have some diplomas here from NASA as well. And we are going to talk about the latest asteroid missions, and we are going to give emphasis for why we want to do asteroid mining to get some metals that they're valuable. We want to use them for their resources. So we're going to talk also about the latest asteroid missions, about Psyche and Hera and DART missions, that we are still calculating the impact from the TAP mission on Dimorphos, and we saw that it worked actually. It crashed on the asteroid, and it deviated the asteroid. So there are still some calculations going on. And also we're going to talk about the near-Earth objects. And if I remember well, by February 25, there were announced 37,500 near-Earth objects. And some of them could be dangerous for impact. And we have the example of Bennu that was calculated that there is a small percentage, actually it's 1 in 2,700, to crash on Earth in 2182. So in approximately 250 years from here now. Sorry, in 2182. And if there is going to be an impact, then the impact is calculated to be equivalent to 1.4 billion tons of TNT. So we're talking about a very large, devastating impact. And also about Apophis. And now the new discovery that was a small percentage of crash, like 1.2%, which increased to 2.3% of chances to crash in 2032. We are talking about the near-Earth object, about a near-Earth asteroid, 2024 YR4. We talked about this asteroid in a previous Science Café. If I remember well, it was 2 months ago. It was or maybe 3 months, February or March. So if you go on the YouTube, you can find it. We describe everything in detail about this asteroid. And also we're going to have a short movie, and then we will end the evening with telescope observations. So you are all welcome. And before we close tonight, I want to remind you all about the International Children's Day on the 1st of June. Tonight we've just announced our event. It's going to take place on Sunday, 1st of June, but in the morning, 11 o'clock, because we want to give the chance and also grow the awareness that people will visit the observatory. They can also visit it during the day, and they can observe the day star, our sun. So we will give visitors the opportunity to observe our nearest star to Earth, our own star, the sun, with 2 telescopes. The one telescope will be available to observe the photosphere, the disk of the sun with solar sunspots, and the other one with a hydrogen alpha filter that will give the chance to the visitors to observe the chromosphere of the sun and explosions, the solar prominence, and so on. And it will be a very, very good experience for those that they never observed the sun through a telescope, or they have never imagined that they could visit somewhere, a planetarium or an observatory, and learn and observe the sun in the daytime. And they will also be able to, we will also project a planetarium movie at the Cosmic Theater. So all these at the same day, and we'll also emphasize on the importance of STEAM education in children's lives, because we see everywhere STEM and STEAM. What is the difference? Of course, STEM is science, technology, engineering, mathematics, and now we call it STEAM because we have some people added art for A, and we add art and astronomy. So science, technology, engineering, art, astronomy, and mathematics. So we want to combine education and entertainment and fun all together in a wonderful environment with scientists, and enjoy the day with families and children. So thank you for being with us tonight. See you again next month on June, last Tuesday of June. It's going to, the next one will be on the 24th of June, same time, 8 o'clock Cyprus time. Thank you for being with us tonight. Have a nice evening.
Thank you.
Thanks. Good night.
Much.
Good night.
Bye.
Good night.
Bye.
Nice guys.
Bye.
Thank you very much.
Bye bye.
Yeah. Bye.
See you.